guys. Right, we're back, finally back with AP Maths. Right, so we're starting calculus. Now, I just thought for like 2 minutes, I'm just going to put it out there. Calculus is a fascinating subject, and I really recommend you to read. There's a little bit of like introduction about where it came from in the book. So I really recommend you reading it, and maybe if you've got some time, research a bit about Leibniz and Newton. But from my side, what I find interesting is that, you've got maths and physics, and they both these subjects are very closely related in a way, kind of like you can think about polo, water polo, and swimming. So water polo, if you're a water polo player, you really want to win. That's what you want to do, isn't it? Okay, it's fun to play and all that, but you really want to win. So you're working on all kind of technique, but one of the things you have to do is fitness. And swim a lot, become strong. So that's the tool. Swimming is your tool to then apply with other tools as well to win the game. And that's how physics and maths are. Okay, so from a physics perspective, okay, I'm really a physicist. I like physics. For me, maths is your tools. So I understand calculus, especially calculus. It's a very powerful tool that then I can use in physics. We don't win games in physics, but we're trying to understand the universe. So I think it's quite interesting. And just a bit about that is that it's fascinating to think how development happens. So there's progress in physics and in maths, okay, at the same time or different times. And it's often interesting to think which progress, or what starts first. Does this progress start in physics, or does this progress start in maths? Okay, and I'll give you an example. So if you look at calculus, which is what we're going to get into, it's been created and fought by Leibniz, who is a mathematician, and Newton, who's also a mathematician, but mainly he's a physicist. And I know from Newton's side that his motivation to start this field of calculus came from physics. He was looking at objects falling. Okay, you looking at acceleration, things like the equation of motions. Okay, these are all differential equations. Okay, we'll understand later what that means. But for him to understand motion, he developed this mathematical tool called calculus. Okay, so sometimes it's coming from the physics side. The physicists want to understand something, and then they create a mathematical tool. Okay, but sometimes it's the opposite. So, for example, you're learning Euclidean geometry. Okay, so Euclidean geometry, but there's actually many other kind of geometries. So, okay, it's not just Euclidean. So, for example, if I take a triangle, okay? That's a triangle. Okay. If I have it on a paper, that's a Euclidean geometry. But if I bend it, okay, now I will have non-Euclidean geometry. So I can bend it this way, I can bend it that way, and what you will find out that I can bend it, roll it like this, and what you'll find out that certain rules that apply in Euclidean geometry, in flat geometry, don't work in non-Euclidean. Probably the best example, I don't really have a ball here, but you know that rule that parallel lines never meet in Euclidean maths and Euclidean geometry. But if you look at a sphere and you draw parallel lines, like the longitudinal line are parallel. Okay, if you look at make a surface, a flat surface of a given point, and you draw these longitudinal, they're parallel. But these longitudinal lines do meet. They meet in the poles. So anyway, there's a whole branch of non-Euclidean geometry, okay? Riemannian geometry. It was done by a guy called Riemann, okay? So he did it, 18th century, 18th, 19th century, something like that. Now, 100 years later, okay, another guy, I'm sure you've heard of him, Einstein, a physicist, he was trying to understand how gravity worked. And he had this idea about curved space-time, that somehow matter bends space. So if there's no matter, space is flat. If there's matter, it gets bent. And then everything moves along these straight lines. Straight line, like in a flat space. But But if it's bent, we also have these straight line. It just don't appear to us that it's straight anymore. But that's not the deal. The main thing I'm trying to say is that his idea, eventually somebody told him, listen, what are you talking about? There is such a thing in math. It's called non-Euclidean geometry, Riemannian geometry. So he eventually got introduced to that with help with others, mathematician, helped him formulate his physics theory in a mathematical tool that was developed before. Okay? So I don't know if similar things happen maybe between water polo, swimming, or running and rugby. I don't know. So sometime the swimmers will develop a tool and the water polo use it. Sometimes it's the opposite. The water polo will say, oh, we need something, and then the swimmer, I don't know. Okay, that's just trying to create that analogy. Anyway, I will stop here. That was a little bit of introduction to calculus. Fascinating. For me as a physics fan, it's the best part of maths. Okay, we will start. I'll do another video to start.